Okay, hello, in today's video we are going to look at fractional distillation. So what I've got here is a box, and that box is just representing a container, and in the box I've got some different shapes drawn out there for you. I've labelled it as crude oil, and that's because I'm trying to represent crude oil, and if you remember from previous videos or previous lessons you've had in science, crude oil is a mixture of molecules. So I could go and label each of these a different type of molecule. So this could be methane, ethane, butane. I'm not going to, I'm just representing it as that. So I've got shapes rather than molecules to try and keep it nice and simple for you. So fractional distillation is to do with crude oil, and that's something we've looked at before. And it's separating the molecules in crude oil. So at the minute we know what we're up to. It's separating molecules in crude oil. We know crude oil from previous lessons is a mixture of compounds, or even there, we know it's a mixture of compounds. So that's the crude oil. We're going to try and separate them. It's not as simple as picking up the square, putting the triangle somewhere different, because when it's a crude oil, it's lots and lots of liquids all mixed together to make one liquid. And if we put it into a glass, it would simply look, if we put it into a glass, it would just be a gloopy kind of liquid, and we wouldn't know where the different molecules are. It wouldn't be as obvious as I've drawn it out in this box here. So it's separating molecules in crude oils, and there are two processes that happen, and two processes that I know you will have looked at in probably year 7 to explain this. So we'll start with crude oil, which is a liquid, and the diagram we often use to show liquids is particles that are touching each other. So these circles are particles that are touching each other. They're all a bit random though, they're not organised regularly, a bit randomly organised, and that's our liquid. And what happens in the first process is that liquid is heated up. So it goes from being a liquid to being a gas. So those particles are redrawn, and they've now got lots of energy, so they've separated out. So you've got this first process that happens in fractional distillation, where we go from a liquid to a gas, and that is called evaporation. So you've got the heating of a liquid as the first process. Process 2 is the second part of this separation technique, and this is when we've got our gas. So we've gone from here, you could always draw a little arrow going round here to our second process that we've already seen before in science, and it's going from our gas, and that gas has cooled down back into a liquid. So we'll draw it with particles that are touching, like I said before, but randomly organised, so it's a bit random, they're not the same as before. So we've got, this is liquid, gas turning into a liquid, and that is called condensation. So that's when gas is cooled down, so it becomes a liquid again. So actually, what we know so far, fractional distillation separates our crude oil molecules, so the molecules in crude oil, and it happens through two processes that we've seen before: evaporation, which is liquid to gas, and condensation, which is gas back to liquid. So what we're going to look at is we're going to look at what it looks like next. And just before I move to the next page, I want to say this is the part, let's do a little star. This is the part where it's separated. So it's heated, they're separated, and then it's cooled back down to become a liquid. Because if we simply heated something up and cooled it back down, we'd still have the same thing at the beginning. So if we were to just put this in a kettle, heat it up, then leave it on the side, it would stay like this. But we're going to use a piece of equipment that allows us, once it's heated up as a gas, to separate it and then cool it back down, so we've got all the liquids separated out. So this diagram here might look a bit funny. It's not something we've used before in science, and it's very different. But remember, the key ideas are that we've got evaporation that we've seen before, when we've heated something that's a liquid and it's become a gas. And we've also seen condensation, where it cools back down, that gas becomes a liquid again. And they're the key ideas. So here, I've got my heater, the crude oil goes into the heater and it heats up. Now if that liquid heats up, that is going to be where the evaporation happens, because what we have is we've got that liquid in the heater getting lots and lots of energy, becoming a gas, and that's what we've just described as being evaporation. So we've already had the first process happen, so that's process 1 has happened in the heater. Now then this gas, so all of this becomes a gas, the liquid goes into a gas and comes into this big container. Now this big container is really special, because what we have is we've got down at the bottom, it's really, really hot, so I'm just using colour to represent temperature, and as we get further away, it gets less and less warm. So as we get higher up, I'm just using colours to show right at the bottom it's really warm, and right at the top it's cold. So we've gone from hot to cold, and that's because we've got the heater really close to this part. So that's the really, really hot part of our container going all the way up to the really cold part of our container. Now that allows us to separate them. So what happens is the gas comes into this container that's got lots of different temperatures going on with it, and it separates. Now it separates based on chain length. So it separates based on how many carbons or hydrogens it has. And you don't need to know this complex reasoning why. You just need to know that it separates based on chain length. And the longer chains are going to be right at the bottom with the high temperatures. And at the top, it's going to be the higher chain, the shorter chains. Okay, so what we've got so far is we've got our crude oil gets put into a heater, heats up, and it evaporates into the gas. That gas comes into the container, and what happens is it's hot at the bottom, cold at the top. So those long chains go to the bottom, the shorter chains go to the top, and they're separated. Now you might think, well, where's that second process? I've said right at the beginning there's two processes, there's evaporation and there's condensation. I also said that star bit is this bit here. It's the separation part, and then condensation happens. So at each one of these kind of points here, that's where we've got condensation. So let's get a new colour. I'm going to just highlight each of these. That's where condensation happens. So I'm just going to put an arrow. Condensation happens. So that's the second part, isn't it? That's the second process that we know about, that we can describe. So it starts at evaporation. They're separated by temperature based on their length of chain, and then they are condensed down. Well, what does condensation mean? We've looked at it earlier. It's going from a gas back to the liquid. Okay, so if you just look back at this, I've said it's separating molecules in crude oils. There's two processes. Process 1's evaporation, so it goes from a liquid to a gas. And then I said the star is where it all separates itself, and then we've got that gas cooling down into condensation. So what is the star? We've gone through it on here. The star is this bit here. So that's when it's separating based on its temperature and how long the chain length is. So I'm going to go through the process one more time in full. So we start off with the crude oil. Goes into the heater and heats right up. So it's really, really warm, and it eventually evaporates. So that liquid becomes a gas. That gas goes into our big container and it moves all the way around, and it separates because there's a hot bottom and a cold top. The longer chains leave at the bottom, the shorter chains leave further up the column. When they leave, they cool down because they're no longer in this hot column. They cool down and they condensation happens. So they condense. back into a liquid, and we've got all of our things separated. So at the end here, we might have our triangle, we might have the rectangle, obviously they're coloured before, but you get the idea, and a circle. Something like that, they'd all be separated based on how long those chain is, so how many carbons and hydrogens there are.